So first up is Birali Runesha from our own University of Chicago Research Computing Center. So, all right.
Thank you very much. Actually, when I was getting ready to prepare my slide for this presentation, I asked my system staff that they've been actually working with Globus Online that I was asked to give a presentation, and then I told them, can you put together for me some slides, some material so that I can use? And my system person responded to me. He said, you don't need to do anything, just tell them that it works, that's it. So as I was preparing then, and then I realized actually we've done quite a bit since the beginning. And what I thought I was going to share with you is what we've done implementing Globus Online and some of the testing and what we are planning to do working with the faculty. But before we do that, just to set the stage, I joined the University of Chicago about a year and a half ago. And when I arrived, one of the things I did was to try to understand the landscape, the various workloads. And the University of Chicago actually is organized by 4 divisions. They don't use college. So the college is actually where the undergraduate programs are. And out of those 4 divisions is actually 19 different institutes. There are centers. There are also committees. This all to just say that there's a lot of variety of research really taking place at the university. And what I also noticed is many groups also were organized with their own research clusters and supports. They also had different providers, and then they really do, from labs to compute, use different means to do their data management and computation. So in essence, really, you talk about the really wide range of research disciplines. By that, what I mean also the requirements and the needs are also different. So when you look a typical data lifecycle, I think we've seen all of this, and you try to follow it from a lab, from an experiment, all the way to processing the data, how it's being analyzed and shared. What are we observing? So as I was walking around campus, you see really your typical researcher will have a bunch of hard drive where they store their data. You will also have a set of servers around the corner that they're doing their computation. And they'll be doing from an instrument trying to move data. In some cases, they'll basically take the hard drive, put it in a closet, and lock the cabinet, and that's secure data. And in some cases, we have people who will drive to APS to drive their data from the advanced photon source because that's much quicker for them to move data back to the university. So in an essence, really, the data management is really quite still poor, even though we have really fast network on campus. And there is also a lot of old and inefficient hardware. In my role, actually, one of the things I'm also very much concerned is the cost of power, because the aggregate of that really end up costing a lot to the university. And then, of course, software, the way they transfer is still ad hoc, and everybody does what they can. And then the performance is also, as a result, very poor as well. So these slides here kind of summarize what I think some of the general challenges that the faculty are encountering. And like I said, among them is also the distributed nature of source of data they are collecting or where they are doing their simulations. It can be from national centers to local computing to the cloud, you name it. And then there's just quite a lot of complexity of issues associated with using the data they are generating. And then, of course, we talked about HIPAA. And one other thing I'm going to just also throw in is also what I always refer to as sensitive data, because we are also seeing a lot of data, for example, coming from the city or FBI. They are not HIPAA, but they're so sensitive that if one gets hold of the data, it would be quite disastrous. So do we build an enclave? How do you secure that? And then by creating all that firewall, we still need to do research. Then how do you move the data from that enclave to where you're going to do the analysis? So all those are really, you can see the landscape of all these issues in this era where research is collaborative in nature and interdisciplinary. So the University of Chicago, in light of all this, has been also thinking about how to answer this. A couple of years ago, an initiative went on to create the Research Computing Center. That's when I joined the university. And the mission of the Research Computing Center is really to provide a centralized computation and high-end computing storage, as well as user support for all faculty at the university. It's not really replacing every existing support, but at least to have a centralized center where you can have a go-to place for all your computation needs. And then in addition to that, we do not believe that having just access to compute alone in this era is what it's required, but we also believe in the consultant and the user support. It's a whole ecosystem for us that we believe is what we provide. Hardware alone is an incomplete solution. And really what we are really trying to go through is really a vision where data, storage, compute had to be simple as a service. Faculty have to really dedicate the time to doing research rather than managing their hardware. We all probably went through this where as graduate students we ended up spending a big portion of our time doing system administration or learning a computer system because that's the only way we could do our research. That's really the mission of the center. Just quickly to just give you an idea what we have done so far. About a year ago, we issued our first RFP, and then we installed an IBM iDataplex, and then we currently have an aggregate of over 325 nodes, and that's really about 5,000 or so Intel Sandy Bridge processors. And these are the 2.6 gigahertz, and we are running an FDR10 interconnect. But what we are really providing, and the model we adopted at the University of Chicago, is really building what we call building blocks, where we have the shared resource where all faculty can have access. This is shared. But we are running what we call a cluster partnership program. In other words, these are building blocks where I'm a faculty, I have my own fund, I can augment any of these building blocks and have my own dedicated resources. We just manage it for them, but that's dedicated to them. But then they leverage all the support, the tools, everything we are building as part of the infrastructure. So the 5 building blocks we are currently supporting is the tightly coupled nodes. These are for your MPI type of applications. We also have the loosely coupled nodes. These are just GigiWare, basically, for high throughput. And then the large shared memory. Currently have a 256 gig, and then adding up to a terabyte of node and GPU nodes as well, going from NVIDIA Kepler. And then on this line, we're going to also have some mic processor. What it means here, out of the 325 nodes, for example, just to give you an idea, half of that only were purchased by the university. The other half are owned by faculty. They are really dedicated to the faculty. The program has been working very well. We opened up last November. This is after 6 months of our being in production. The result has been quite good. The last building block we are introducing, by the way, is a Hadoop map-reduced nodes. This will be available in 2 months. And faculty, we got a lot of demand as one of the things that was missing. And then we hope this will be also the 5th building block that we'll be making available. On the storage side, this is our typical tiers of storage. You have your typical home directory where we have a limited space. And then we have 2 things. We have the capacity storage and then the high-performance storage. The high-performance storage is your typical scratch space that is attached to your cluster. People usually don't keep their data there. We do not back it up. And capacity storage is where people store their project files. On the storage, the same way we have a partnership program, you can augment the compute nodes. You can also augment the capacity storage by adding on our existing storage. And then we do run a tape backup with, for our data. So when you have data at RCC, basically you have your data in your capacity or project space, but we also have a copy snapshotted you can access anytime, and then another copy on the tape. So we do provide that reliability. So that's about our compute. Just to give you also an idea, we opened up last November. That was when we went into production. So we started kind of tracking the number of users. So since we opened up, you can see we use this concept of a principal investigator, which means you have faculty, but you can have 10, 20 students in your group. We already have about 60 PIs. And then when you look at the number of researchers, it's already reaching about 250 or so. Those are the people actually doing their research on a cluster. So what I did also, I tried to track, of course you're starting a new cluster, and you say, how is the people are moving their data to the cluster, to our storage. So we were tracking only the project space in capacity because people can't keep data on the scratch space. Then you can see here in blue is really the amount of terabytes that have been moved in and out on the storage. And then in red is the really number of files. Just pay attention here. Basically, you really around here we had almost around 250 terabytes or so, but then went up almost 250. And this was one of the users, one single user that was accommodated that I will show you later on, that was really moving data from Stanford to Chicago to exceed resources. And then, but they were doing also the research on our cluster. And then this already gives you already an idea when people are moving all this data, how are they moving the data to RCC? And that's where actually for us, the use of Globus Online, the transport part actually was really tremendous. And then I'll just give you just some selected example. And then we, in the same time, this is just the beginning, people are still migrating data as we speak, and I anticipate this graph will just continue to grow. So this is my favorite, actually, story. When we open up in November, of course, you have your typical people will do SCP, they will do rsync, there's all these means of moving data. But there was one faculty that was really waiting to use our resources, and when we were ready, I said, okay, I would like to move my data. And then we didn't understand why they was making an appointment, but it turns out to send their stuff. It was basically showed up with a bag of a red bag with a hard drive in it. Real story. And then that was his data because they are accumulated. And then of course we had to take the data, have them move the data on. And the mean of the transport utility you can take is basically this red bag here. And I think the network probably might be that working on Midway, like to bring in, because we are past Midway Pleasant, to cross to the where RCC is. But this is only the reason I'm bringing this up is actually it's not the only person. There was also another person who was driving to Argonne for APS data because it was much faster for him to bring data from APS to Chicago driving it. So this is just to give you, say, we are really, even though we have all these means, the simplicity, the performance, we talk about them, but they become really critical for many, many people. Because as we are moving from here to all this hardware we are installing, Chicago has 10 gig connectivity all the way to storage, we're upgrading to 100, so the connectivity is really there. And then it means, I mean, of course, installing Globus Online in here, also had the SCP, but the performance of Globus Online made it even much an attractive means of moving files. And then the network connectivity, Chicago is really upgrading to 100 gig as we speak. Now, what did we do then to implement our Globus Online? You saw Steve yesterday demoing from the RCC. Currently, when you have your account at RCC, you don't really need to register with Globus Online, which means we have our endpoint. You can go globusrcc.uchicago.edu, and basically you'll be ready to use. One other thing also we are actually even moving forward is to even make even simpler is we created something we are promoting. It's an RCC and IT Director Alliance, because we also want the faculty to install the Globus Connect on their desktop. Then the question I've been posing on campus is, as the desktop support, why don't we bundle that as our deployment on the faculty desktop? When we image the desktop of the faculty, basically it comes already installed. Even though it takes less than a minute to do, but sometimes, for various reasons, it can delay the faculty being able to use. As to just still really make it as simple as it is. So we saw the skin image when you connect to the UChicago authentication. We are still working with the Globus team to even bypass that CR login, also even selection, all this to just make it easy. Even though I might say once you log in, like on mine, I usually have it and I don't even do it multiple times. So it's already simple. I can even make it even simple. I think I always tell my staff if I can do it, I think everybody can really do it. And I went through it and it didn't really take me even much time. And then, like everybody, I'm sure most in this group have tried it. It just works. And then there's also some people who still like to use the command line, and actually my staff in particular, they still love using command line. All of that just really works very well. So we hope at Chicago as a model, we'll be supporting on the end on the RCC. We are promoting to embed it also in the deployment desktop so that the faculty can have it ready to use whenever necessary. I think you saw already, we have been playing also with some of the demo. So the management of endpoints are already available on the beta version that we have. Actually, that's how I was checking my endpoint that when I was preparing this. And then actually, the transfer of activity, this is also something very useful. I just want to point out, is basically, it really kind of helps you see the completions and whatever you've transferred. And one thing I also really want to point out that is not really usually very made available, there is a lot of useful information that the Globus collects. Actually, for us as a research computing center, we find very, very valuable. When you track all the number of files transferred, how long it takes, and the amount of bytes, I think for us, it helps you track if really the end-to-end is also tuned. We work with the network service at the university, and those usually provide a very good indication. So just a couple of few examples that I kind of grabbed from the emails. There is a lot of faculty at the university that move every time we hire a new faculty. And this was an example of a new faculty coming from Princeton. And when they contacted us, they say, well, I have almost a 1.5 terabyte I wanted to move. I think she had done some rough calculation. It was going to take her almost 3-4 days to just move the 1.5 terabytes to Chicago. She's just arriving, and she didn't want to really have any interruption in her research. And she just really said, what is the best way I can do this? So use Globus Online. Actually, we just asked her to install the Connect on her side. And the email I just followed say, holy cow, this is really verbatim from her email. She say, this thing is fast. And she's been a lover since coming to Chicago. As a matter of fact, we manage her group. She has collaborator also in France. And then before you know it, the guys from France were also doing the same thing. So very real story here. This is also another good example I just kind of selected. A couple months ago, I believe in December, there was an MRI system that was actually at Argon pads that was being decommissioned. So we had a number of researchers that they had to move their data to RCC. And then you could see here, basically, same thing for 45 million files moved, 10 terabytes. But the only thing I just wanted, this was pointed out, when you look at some of the files, how they are transferred per day, it really gives you a lot of useful information, because for us, sometimes we don't know when the system is down or the network is congested on what. And then there's also another user that moves 60 terabytes or so. Just quickly, this is the example I was talking about. Matt Becker was actually February 2012. I think Globus Online had this best geo user of the month. But that particular user was the one kind of pushed this usage of data by moving almost about 100 terabytes or so away from Chicago to Slack and Exceed resources. One thing I just want to quickly, as I end, to talk about, we've been experimenting with the sharing feature of Globus Online. A lot of the faculty have their collaborators, and the way we are doing things today is what, for me, I believe is a little clunky. We have a collaborator in France. He doesn't have any affiliation with Chicago. We have basically to create fake IDs for them to have an account and to share files, for example. We've been experimenting with the global sharing. I think we are really excited about it for us, because it's going to take away a lot of these headaches from us, because we give in really the flexibility to the user. We don't even have to know what they are doing or sharing with. And the user basically going to be the one providing the sharing and the capability. Very, very, very useful. And then the other thing also the staff takes is creating project space to share files, and all that really kind of nicely taken care of, the same way is being taken care of the transport. So it's working at UChicago. We are actually moving selecting now pilot research group with whom we're gonna basically now provide this to them, demo it to them basically for that they can adopt in production and make arrangements for payments or subscription with the Globus team. I know I'm running late with time, but I just want to end with this slide here to say there's really a laundry list of advantage for us. We can go on and on to list about the feature of Globus. But for me, the simplest way to summarize it is very easy. It works, and it's really they perform very well. Thank you for the time.
Thank you. Very nice talk. One of the things you mentioned in your introduction is that you've deployed 3 levels of storage for your users. You've got your high-speed scratch, you've got your large project directory, and you also have a tape backup. Mm-hmm. And how is that exposed, or is it not exposed? Do you have hierarchical storage management to move stuff between those? And if it is exposed, what does that look like in the Globus Online endpoints? Do users have to think about how they're moving things around? Can you talk about that a little bit?
Yeah. So currently we are using GPFS. So with GPFS we can move things, and then on the tape backup we are using GPFS and TSM. We are adding HSM to also use the tape for. So there be some policies you can put within GPFS itself. So currently the way we are exposing it is really moving the data to your project space, and from there you are using your GPFS, your normal account to move data from one place to the other. But the tape and that is done automatically. So we back up every night. The snapshot is done automatically. You can access every hour. But we haven't done a lot of complex to do management, but it's on our roadmap. Like I said, it's 6 months. We've been really quite busy deploying quite a bit, but we have an overall plan of putting a digital archive and we are hoping, we're waiting for that to be installed so that we can think of a good way to really create a tiered or depending on the requirements that the different research groups are going to be requesting. I just need to mention one thing though, because we have a shared portion. We have all these groups that have their silo of their own needs. We are struggling with the different faculty requirement wanting XYZ and how to coordinate the support all of that. And that's one of the things also we are juggling on how to minimize the staff time and be able to at least support all the different variety of requests that are coming from the different faculty that are giving their own funding.